So we're going to start off with the first unit, Mathematics of Finance. So if you don't like this unit, the good thing about this class is each unit is designed to be mutually exclusive of any of the other ones. If you don't like this unit, well, good news. The next unit has nothing to do with it. If you do like this unit, then bad news, next unit has nothing to do with it. But this is the structure of the course. And mainly for this section, we're going to be talking about things pertaining to loans, things pertaining to investments. We'll start off with interest for the time being, simple interest. Start off with simple interest. Workbook assignment, I have a big old blank here because I don't have the workbook. So we're going to leave that alone for now. I don't know. I'll say stuff about it later. So don't worry about that. Instead, I'm just going to casually explain what simple interest is. Because simple interest, well, interest in general, you can think about that as a fee. It's a price, if you may. It's a fee for doing something, of borrowing some money. Or it could work in your favor. It could be an incentive for investing. So that's interest. So for example, I'm going to pick you up for no particular reason. Let's just say I want to borrow 50 bucks from you. And you say, all right, well, I say I'm going to borrow 50 bucks from you, and I'll give you 50 bucks back in a month. And you say, well, wait a minute, what's in it for me? I'm loaning you 50 bucks. What do I get in return for that? And I'll say, all right, fine. I'll give you $5 on top of the $50 I pay you back. And so that $5, that would be the interest. That's the fee that's charged. And of course, banks do this all the time because, they're not really your friends. They want your money. And so this is how they make their money back. You pay them, if you take a loan out, then you pay some fee to take that loan out. You don't just pay it back and you're all even. It doesn't work like that. They're not your friends like that. And so one of the, and I suppose not to get ahead of myself, for this first example, this is really going to demonstrate something called simple interest. For simple interest, what makes it simple? For one price, there's one fixed fee. That fee does not change. That fee is just instantly figured out right when you borrow. Or in addition, if you made an investment, then they would immediately tell you how much money you would get back at the very end. So pretty much you'll get this money back, plus we'll give you some money for letting us have this money for the time being. So it's simple interest. It's a fixed fee or a fixed incentive. And so the most basic form of this is taxes. So as I most recently checked, the sales tax rate in Hammond is 9.45%. And so find the tax charge on, say you purchased something that's $26.21. Perhaps you got some clothes from Target, or you and your friend got a lot of stuff from Chick-fil-A. A lot of stuff from Chick-fil-A. So what is the tax charged on this purchase? Because as you know, the price tag never gives you the full price. So we have to do something where we take the $26.21 and determine how this 9.45 affects it in order to get the tax, or in other words, that particular percentage of 26.21. Now, some of you might already know how to do this, but we want to multiply not 9.45%. So we never want to use the percent value, or else it's going to say that you're going to pay a tax of over $100, which wouldn't make any sense. What do we have to do with that percentage? Anyone remember? Well, someone just raised their hand. You can go ahead and say it. But
I think what you're supposed to do is turn it into a decimal value.
So a decimal value, and then of course, in a capricious manner, I say, but there's already a decimal. Wouldn't that make it a decimal value? You move the decimal to the left 2 times. Or in other words, you take the quantity, and I bet that's what you meant for whoever answered virtually, but you move the decimal place over 2 times to the left, or in other words, you divide the quantity by 100. And then that's the number you want to use. And then that simple quantity, whatever that comes out to be, and in fact, this semester, starting this semester, I'm going to start utilizing a virtual calculator. Very excited to finally get my hands on one of these. So now you can all see what I'm doing, mainly because I make frivolous little mistakes all the time. And now you could see if I make a mistake, you could tell me. So I do it every now and again. So let's 26.21 times 0.0945. So I get 2 point blah, blah, blah. And I'm going to round to 2 decimal places because this is money. Dealing with money, we want cents here. So, oops. So 2.48 to round up to the nearest cent. Since this is money, we're figuring out the tax. And so that's the tax right there. Very simple. We just found 9.45% of $26.21. So that's it. Found the tax. You may have already known how to do that. If so, cool. If not, there you go. How's everyone feel so far? Is that fine? Well, let's refine this a little bit more by we'll start to give everything some terminology. So the original amount that you borrow or the original amount you invest is called the principal amount. So we're going to be using that term a lot throughout this section. Loans incur a fee for borrowing known as interest. Interest is the fee. The interest is normally computed as a percentage. The percentage is the interest rate, the rate of interest. So that would be like the 9.45% from the previous example. And so we bring all of that together. Now we have the principal, first letter P, interest, first letter I, interest rate. Well, I is already taken, so we're going to use R. And now we can bring that into a nice formula. Now we have some nice refined terms to categorize a formula out of. So simple interest, our first formula in this class, how exciting, is given by I is equal to P times R times T. So if you know the principal, the original amount, you know the rate, which is going to be a decimal, like we did in the previous problem, and T is time, then multiply all those things together, there's your fee. That's it. Very basic, very simple, in other words. So, as I mentioned, the interest rate, like we did in the previous problem, the interest rate is a decimal. You don't want to use the exact quantity, or else you will get some very large answers. It will say your fee is probably larger than your original amount, which doesn't make any sense. Generally fees, I mean, if that were the case, then why would you want to borrow anything? And the amount of time it takes, we're going to convert time to years. And so we'll see what this means. There's a few problems that will give us months, and we'll have to figure out how to write that in terms of years. If you have an idea, then maybe think about that, and we'll see if your idea reflects properly. So we'll leave that up top, and we'll move on to example 2, which is a very simple problem. Find the interest given some basic values. Okay, so normally what I like to do, I mean, you might already be thinking about what to do, but what I like to do, which generalizes the best. So I'm a very organized person. And the reason why organization will help facilitate your steps. It's been helpful when I was a student here 10 years ago. It was very helpful to be organized. And so the organization process here, off to the side, I'm just going to remind myself that this is simple interest. And right below it, I'm going to determine all of my variables. So we know the formula. We know the formula, and what letters does the formula have? It has an I, a P, an R, and a T. So I'm going to jot all of those down, and I'm going to physically write out and convert everything I need to off to the side first. I've seen that this helps so much better than trying to convert in line if you write the formula and do stuff like that. I've just noticed time and time again, this helps facilitate thoughts and ideas a little bit better when you break down bigger problems to smaller ones. So the problem says find the interest. So obviously the interest, I, it's unknown. We don't know it. That's what we're looking for. So we just put a question mark. The P is the principal or the original value. So I only see one value here, so that makes it a little easier. So $13.50. And this is at 6.5%. Naturally, that's a rate. So I'll go to put 6.5% down, but I have to remember that I'm not going to use 6.5 in my formula. So I'm not using 6.5. Instead, I'm going to bump the decimal place over 2 places to the left and convert it to its decimal form, or divide the number by 100. So 0.065. So I just go ahead and do the conversion over here while I'm at it. And then, of course, T is time. That should be evident at 3 months. But the formula up top, at the very top of this page right now, says we have to write that in years. You might think, how do you write months in terms of years? 3 months isn't even 1 year. How do you use a fraction? So how do you get a fraction out of this? How do you know what fraction to use? Yeah, it's 3 over 12. So for those of you who just raised your hand, yeah, it's 3 over 12. And pretty much the generalization is you take whatever your number is and you divide it by the number of occurrences in a year. There's 12 months in a year. So that's why we put 12. That's 12 months in a year. So that's 3 over 12, which I'm going to go ahead. Students like decimals more, so I'm just going to put the decimal form. 3 over 12 is 0.25. So it's 0.25 years. Decimals normally help a lot more with the formula. So there's our simple interest right there. And now when we write this formula, we don't have to worry about anything except for, well, plugging everything in. The formula, I wrote it first, just to remind myself. The P is 1350. The R is 0.065, and the T value is 0.25. And, well, guess what? It's calculator work from here. I see 3 numbers multiplying each other, so I'm going to go ahead and multiply those together using this cool virtual calculator thing. So 1350 times 0.065 times 0.25. And so this is, the interest is a fee, so this is money. Naturally, I'm going to round to the nearest cent, unless the problem tells me otherwise. But this is $21, and I'm going to say 94 cents. 94 cents. The 7 bumps the 3 up to a 4 for that second decimal place. And so that would be the fee. So if you borrow $1,350, according to the premise of this deal, you pay a fee of $21.94, which really isn't too bad. It's not really that bad at all. So, so yeah, pretty straightforward implementation of the formula. Everyone okay with that? Pretty straightforward. So let's bump up the difficulty a little bit more. Figured everyone would be okay with that. So let's Let's go a little bit further. Let's throw some algebra into the mix. Now, everyone here loves algebra, so let's throw some algebra in here. So another simple interest problem. So I'm already going to get started with the IPRT labeling. So luckily for us, they even tell us I is 36. They tell us R is 4%, which, like we did in the previous problem, we can rewrite that, move the decimal place over once, twice. Here, 4 didn't really have a decimal that we could see, but we know it's right behind the 4. And so 4% becomes 0.04, or 4 divided by 100, in other words. And the time, they tell us it's 9 months, but we know, wait a minute, we don't use 9 months, we need to convert that to years, so we do exactly what we did before. Take the 9 and divide it by how many months are in a year, that's 12, and we can convert that to a decimal because people like decimals more. So 0.75 years. So from there, we go straight to our formula. And now we can just plug everything in after we've now converted. And notice the P is unknown. So not the I anymore. We're looking for we know what the fee is, and now we need to figure out the original value. The I is 36. The P is unknown. If it were known, we would have a number for it. The R value is 0.04, and the time is 0.75. Now, the problem here lies in the fact that the variable we are looking for is not isolated. It's next to all these numbers. It's kind of gross. So we need to, well, make it not next to all those numbers. The first thing I see, though, I see 0.04 times 0.75. I can just go ahead and multiply those numbers together. Make it a little bit easier. Just clean this up a little bit more. 36 is equal to P times 0.04 times 0.75. I've done this problem a few times today. I know that's 0.03. So I'll just go ahead and jot that down. And so now this is really cleaned up, but the problem is we're not done because P is not by itself. P is being multiplied by this cumbersome number. So what do we do?
0.03 of those things.
Yeah, since P is being obstructed by a multiplication, how do you undo a multiplication? You divide. The opposite of multiply is divide. Divide both sides by 0.03. And so that gets P by itself. So P is the result of 36 divided by 0.03. And again, I've done this problem enough times. I know this is 1200. Or I believe it's 1200. I can check that to make sure. I'm pretty sure that's 1200. It is? Okay. I'll take your word for it. All right, that's 1200. So we get that the original amount for which the fee of $36 was applied to was that person had to have borrowed $1,200. So how's everyone feel? Yes?
Would you care, like, if you don't put the dollar sign in the middle of, like, before the answer? Like, can we just write 1,200 or?
So really, it's a matter of, oh yeah, I see the discrepancy between my first one and second. Really, it comes down to, so my math lab, because personally, I'm not picky at all. I don't care about units or dollar signs or anything, but my math lab is, it's a machine. It doesn't have sympathy like humans do. And so it won't make you put a dollar sign. Yeah, so you could put the dollar sign if you want it to look fancy, but you don't have to. Like I should, I guess, on my end, put a dollar sign. You really don't have to, though. Dollar sign. You know what I'm talking about. All right, cool. Anyone else? If not, let's get going. I'm on a good roll here. So let's move on to example 4. Put it right there. If you pay $47 to a loan company for the use of $1,374, it's interesting, there's $2 amounts here, for 165 days, what annual rate of interest did they charge? And assume a 360-day year. A lot of interesting information here. Let's break down the problem, because this one's a little bit more difficult, because now they're not telling us which one is which, and we have to figure them out on our own. Okay, so we'll start off, do the whole I, P, R, and T thing. Okay, so now we need to figure out which one is which. I think there's one of these that's more obvious than the other. Time, 165 days, but we need years, not days. Days won't help us. So we need to take the 165 and divide it by the number of days in a year. Now, intuitively, we would say 365. However, if you know my math lab, you know it's picky and it kind of does its own thing sometimes. My math lab, for quite a few of these problems, will throw in, assume a 360-day year. Assume that there are 360 days in a year. And you might think, why? Why, my math lab? Why would you do this? This is just, I don't know, hurts my head thinking about it. But, so since they're forcing us to use 360 days in a year, then that's what we're forced to divide by. I figured out because it actually makes the computations look nicer if you stick to fractions, but we're gonna use decimals. So we're gonna convert that to a decimal, and you might have already noticed, if you use the calculator to say 165 divided by 360, you get that thing. It's a repeating decimal. It doesn't end. So you might think, all right, well, what do I use for my decimal then? You can use every single decimal value there if you want, or you can round. The problem with rounding is if you round too quickly, you're going to screw up your final answer. So you have to round at the right place. And really, there's not technically a correct answer for that. I normally do like 6 decimal places because I don't feel like writing all those numbers out. But if you round too quickly, you may screw up your final answer. You may be off by like 5 cents. And according to my math lab, that's all the difference to count it wrong. So I'm going to use 0.45833 years. Oops. I generally use 6 decimal places. Probably 5 would work as well, or you can use every single value there if you want. It doesn't matter. But with that, putting that aside, let's figure out the other values. I see the $47 and the $13.74. Now, one of these values has to be I, and one of these has to be P. Because obviously none of these are rates, because rates are expressed by a percentage. So one assumption we can make is that the rate is unknown. Because we have 2 monetary values. None of those can be the rate. And additionally, what annual rate of interest? Also says it right there. It asks for the rate. So the rate is unknown, and now we need to figure out, is the $47 the interest? Is the $13.74 the interest? And which one of those was the original value? Well, if the $47 was the principal value, then that means you would be paying a fee of $1,374 to borrow $47. Does that really sound fair? Not really. Why would you want to pay over $1,000 to borrow 47 bucks? So, by that simple fact of logic, the fee is $47, and that's to use $1,374. So you can use that thought process. Sometimes that'll help when deciphering which value goes where. So move that to the middle, and I'll start building the formula over here. P times R times T. And let's go ahead and start plugging everything in. $47 is equal to $13.74 times R, which is unknown, times 0.458333. So I just plugged everything in. And so now, R is not by itself. So the first thing I'm going to do is simplify what I can. 1374 times the 0.458333. Just go ahead and multiply those together. 1374 times, and if you wanted to use the exact value every time, so if you wanted to use the previous value here and not have to type it in, you could press second, so the second up here, and all the way down here it says A and S. You could use the exact value here. That's for those of you who are a little bit more comfortable with the calculator. For now, I'll put 0.458333. And really, you'll get a different answer if you do that versus if you did it the other way. If you use all the digits, you'll get this number. If you don't use all the digits, you'll get this number. Both of them are fine. It's just rounding, but the rounding is okay because you used enough decimal places. To stay consistent, I'm going to use the one with more decimal places. But if you get a different answer, don't think that that means yours is wrong, because you will find that the final answer will still come out to be the same. So let's see, that is, I'm going to use the 629.749542. But if you use the 629.75 using your rounding method, that's still correct. That's still fine. You will get the same answer in the end, I promise. So from here, now we clean this up considerably, and it's R that we need to get by itself. So how do we get R by itself? We divide. It's just like the previous problem. We cleaned it up, and then we divide it. We're going to divide both sides by 629.74, blah, 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 blah. And I'm not going to write that number again. It goes right there as well. So now we have R is equal to 47 goes on top. 47 divided by 629.749542. What does this tell us? 629.749542, and we get this number. 0.07, I'll just write all of them because we're at the end. So we get this number, and you might think, all right, we take that number, and I believe for this problem, they ask you to round to 2 decimal places. And you might think, all right, well, the answer is 0.07. That's not the answer. You might think, come on, why is that not the right answer? We did everything. We followed all the steps. So remember, rates can be represented as decimals and percentages. Guess which one we have? We have the decimal. Guess what we need to represent this as? A percentage. We're working backwards. We go from a percentage to a decimal to use the formula, but now working backwards, the formula is giving us a decimal for which we need to convert to a percentage. So how do we do that? We multiply by 100 or move the decimal place over 2 times to the right because we're working backwards. And this gives us a percentage. So now this is going to be 7.46%. And in my math lab, it'll already have the percent sign afterwards. You won't have to put in the percent sign. But now this is a percent. And I'm rounding it to 2 decimal places after I move the decimal. So that's why I'm including the 4, 6 only. And this would be the interest rate. So that one's a little bit trickier. So notice we slowly go up in difficulty a little bit more. So does anyone have any questions before we move on to a new formula? Okay. Well, let's move on to said new formula. I'll leave this there for now. Okay. The future value of simple interest. So what this formula says, it's not an entirely new formula in the sense that this is not telling us a new method of simple interest. What this formula does is it takes the previous formula and adds something to it. The previous formula found us the fee. It told us the interest, the fee. But now what this formula does is it just goes one step further by adding the fee back to the original value, thereby telling the borrower how much they have to pay at the end. This may be clear by the fact that in the formula, well, here's P, and PRT is the interest. So in essence, that's what this formula is telling us. It's telling us that we're adding the original amount to the interest, because the interest is PRT. So that's it. So from here, we can, well, we're going to utilize this new formula to just skip the interest. We never have to really figure out what the interest is. So instead of you telling me, all right, you owe me $50 plus a $5 fee. Now you're just telling me you owe me $55. That's it. It just skips finding the interest. And the only new formula we have, so we lose I in the formula, but we add an A. An A just means the future value. Everything else stays the same. Now you may notice this footnote I have at the bottom. What this footnote says, if you're using this formula up here and it asks you to find P, the principal value, then the first step you should do is factor out the P. So this is an algebra term, or an algebra idea of factoring out, or in other words, use this form if you're looking for P only. If you're looking for A, R, or T, don't use that form. If you're looking for P, well, guess what? Use that form. And we'll see this later on. Let's go ahead and skip to example 5, which example 5 is a kind of tricky algebra problem I saw in the homework that I wanted to talk about. Everyone knows how to do it. So they're telling us to start off with that form and solve for R. Now, above I said use this form that I'm highlighting right now. use the top form to solve for r. So in order to get to the top form, we're just going to distribute. A is equal to P plus P times R times T. Now we're back at the top form by distributing. And so notice there's no numbers in this problem. This is a pure algebra problem. This is all letters, which is why I wanted to talk about this one. But to get R by itself, remember, to get something by itself, we normally do reverse order of operations. So that means take care of addition and subtraction first. So the P is being added. So we're going to subtract the P on both sides. That cancels out over here. And so we get A minus P is equal to P times R times T. So now we have the term PRT by itself. All right, we did all the addition and subtraction. What's next? Multiplication and division. So this is P times R times T. So in order to undo multiplication, we have to divide P and T. Divide P and T. Because dividing P will get rid of that one, dividing T gets rid of that one. And so we're actually done, because now R is by itself, and we conclude with A minus P divided by P times T. So if those series of steps were a little bit confusing, that's okay. That's not what this section focuses on. It's more so the numerical aspects of this. But this is, or at least a problem very, very similar to this will be in your homework. And I wanted you all to have an idea of how to go about it. But more so, I don't want to focus on the algebra too much. I want to focus on something like example 6, which is, now we're back at numbers. Use the above formula to find the future value A. So they want us to use the new formula we have, which I'm going to write it down, is equal to P plus P times R times T. They want us to use this new formula that we introduced at the beginning of the page and find the future value. So now, pertaining to this formula, the unknowns are A, it's not I anymore, it's A, P, R, T. And luckily for us, they tell us that A is unknown. Cool. Tell us 4,000 is the principal. They tell us 9% is the rate, which I'm just going to go ahead and quickly convert that to 0.09. So moving the decimal place over. And the time is 2 quarters. How do you convert 2 quarters to a year?
That's 0.5, right?
It does come out to be 0.5, but how do you get 0.5? It's 2 divided by 4. So the logic is always you divide 2 by the number of times that thing occurs in a year. How many quarters are in a year? How many quarters are in a dollar? How many winners are there in the quarterfinals of any sports in any sports league? 4. So 4. I think the prefix QUAR, I believe that's it. And so that's 0.5 years. So we get a nice decimal. So luckily we don't have to round anything. So let's plug everything in. It seems pretty straightforward. P is 4,000 plus another 4,000 times 0.09 times 0.5. And, well, the good news for us, the unknown is already by itself. So guess what? This is calculator work. All we have to do is pull up the calculator. Whatever it tells us, I'm fine with. Plus another 4,000 times 0.09 times 0.5. And that number looks familiar. And you can put the dollar sign if you want. This is money. You don't have to. But we get $4,180 even. So that's it. That's the future value. That would be if you borrowed $4,000 with a simple interest rate of 9% over a half a year, you would end up paying back $4,180 after the half year that you borrow it for, or whenever they tell you to give it back, which would probably be at the end of the time. All right, is that implementation fine? If so, as you imagine, let me step it up a notch. We'll do one more problem. So let's look at example 7. So, all right, now they're using a bunch of interesting wording. What is the purchase price of a 50-day T-bill with a maturity value of $2,203? Blah, blah, blah. So let's write out our givens. So there's A, there's P, there is R and T, since we're using the same formula as before. So if anything, I think the 50-day part makes it clear that time, days, they do assume that each year is consisting of 360 days. That will be 50 divided by 360. So what number are we going to use here for that decimal? I'm going to round it to, let's say, 6 decimal places. 0.138889. So there's 6 decimal places. That'll be for our time. Okay, the rate, I'm just going to go ahead and convert the rate in one step. 0.6108, because they do tell us that the rate is 6.108. I can go ahead and move the decimal place over twice to the left, and that's why I have the conversion already there. Now it's a matter of the 2,203, is that a final value or an initial value? Well, they want us to find the purchase price, and then they tell us that the maturity value is 2,203. What does maturity make you think of? Old. So this is a value that will mature over time. 2,203 is a final value. And they want you to find the purchase price. How much did you pay now, or how much did you get now, so that way this value grew to $2,203 later. We're looking for P. Now, before I start plugging everything into the formula, we have to use the right formula. Oops. We have to use the right formula. Remember, the footnote I gave said, if P is unknown, use this one. So I'm going to use that one. So I'm using that form instead of the other one. And I'll go ahead and write it down here. A is equal to P, 1 plus RT. Oops. A is 2,203. P is unknown, 1 plus 0.06108 times 0.138889. Since we're running low on time, we're going to put all that together. One plus 0.06108 times 0.138889. I get this value. 203 is equal to P times 1.00848334. And then I'm just going to skip ahead to P is the division, 0.00848334, which comes out to be 2203. Then as soon as you're done writing all this down, you can jet for the day. This is money, so this is $2,184.47. A loan of $930 was repaid at the end of 18 months with a check for $950. What is the annual rate of interest? So remember, we had two formulas we looked at really. One of them was the interest formula, I is equal to P RT. And I'll use OR because in this problem, we're going to figure out which one applies to this problem. P plus P times R times T. So the question is, which one do we use? So some of these questions may not be explicit about which formula to use. And you have to use the context of the problem, some of the little characteristics to figure out, all right, does my problem have an interest given to me or a final amount? So that's sort of the thought process you will have to use moving forward as these problems get mixed in together. So reading this problem, a loan of $930, so I think it's clear that this is P. A loan of $930 was repaid at the end of 18 months. That'll represent time with some conversion. We'll worry about that later. With a check for $950. Now, $950, that could be the interest or that could be the final amount. Does anyone have any guess what that may be?
Which one, second?
What's that? Well, the $950, what you got? That's going to be the final amount. It wouldn't make sense if your fee is larger than what you borrow. Sometimes if you borrow a lot and there's compound interest, it ends up being that case, which is pretty interesting. But this is going to be the final amount. So that already tells us which formula to use. Remember, the I formula, remember, interest is a fee. I don't see a fee in this problem, so it wouldn't make sense to use a formula that has us utilize a fee. We're going to be utilizing this bottom formula here, which tells us which variables we should expect. There's an A, there's a P, there's an R, and a T. We already figured out some of these. 950 is the final, 930 is the original, and the time is 18 months. But if you remember from the last class, we don't want to use the quantity of months. This formula needs to utilize years. So how do we convert 18 months to years? Just divide by 12, because there's 12 months in a year. That's it. I believe this is 1.5. I like to use the decimal. Decimals are a little bit more familiar with people than fractions. So if you're comfortable with the fraction, you're more than welcome to use it on your own. So 18 months divided by 12 months in a year, that tells us that 18 months is 1.5 years. And so, well, really, process of elimination, R has to be the unknown, which is also characterized by what annual rate of interest, which is, what's the rate? So we know all of our values. A is 950, P is 930, another P, so another 930, times R times the time, which is 1.5. So I just plugged in all of our givens. So here's pretty much our scratch work off to the side. And so now we need to get R by itself to figure out what R is. The problem with this, well, since R is not by itself, algebra is going to have to come into play. It's inevitable. But we can clean this up a little bit, not make it as bad. So what can we do first? Do you have any idea?
Numbers on one side. We'll add up the.
So ultimately, the goal is to get all the numbers on one side. So let's do this a step at a time. What you got?
Multiply 930 by 1.5 and then divide by R.
So let's start off with that idea of multiplication. So my first intuition, or maybe for a lot of you, you might think, let's just add 930 and 930. Don't do this. You cannot do this. I've seen it happen. I've taught 105 quite a few semesters now. People get this problem wrong all the time because they add those two numbers together. And it's so tempting. They're right next to each other. Why can't I add these darn numbers together? It's because of order of operations. You have to take care of any multiplication first before addition. So what is it? Parentheses, exponent, then multiplication and division. You have to take care of any multiplication first. And the reason why these 930s don't go together is because the 930 is multiplying 1.5. So those are the numbers. So that's the reason why we have to multiply those two together first. 930 plus, and as I did before, and I'll do it for this class as well, I have one of these fancy TI calculators, so you can all see what I'm doing. So 930 times 5, it tells us we get 1395 times R. Because the R doesn't disappear, it's just hanging around. Can't really put R in the calculator, so it just kind of lingers for now. And so you think, now we can add these two together. I did all the multiplication, so now we add these two together.
You have to do division next, don't you? Or
You could. It's going to get messy if you do division next. It's not wrong, it's just messy. What you got?
Subtract 930 from both sides.
We're going to subtract 930 from both sides. And so you think, well, why don't we just add those two numbers together? I mean, you got some arrows pointing to them. Can't do that because the 1395 is still multiplying the R. And you might think, well, there's nothing to do there. The point is exactly, there's nothing you can do there. You cannot break up that multiplication. So the aforementioned addition can never happen. That addition cannot happen because that 1395 is stuck with the R. You can't just split it up and just add it off to the side. That would be the equivalent of 1 plus 2 times 3, and then saying that this is 3 times 3, which is 9. But in actuality, 2 times 3 is 6, plus 1 is 7. So that's an example of that. You don't really have to think about it that way, but if you wanted a counterexample. So instead, as you mentioned, subtract 930, subtract 930. That's all you can do right now. That is the addition and subtraction you can do at the moment. So 950 minus 930 is 20. And of course, this cancels. And we're left with 1395 times R. And now we simplified this very nicely to where now the division is going to be, well, as simplified as it could possibly be. So we're going to divide both sides by 1395. 1395. Move that over. So now R, since of course R is now by itself, R is now 20 divided by 1395. Well, let's just put that in the calculator, see what happens. 20 divided by 1395, and we get not very nice looking decimal. 0.01433691776. So you might look at this and think, okay, so the answer is probably 0.01 because normally they ask you to round to 2 decimal places. So you would look at this and say, all right, it's 0.01, but it's not because of an interpretive final step we have to do. In the previous problems, so you might or might not remember, but when we were given the rate, say 7%, we had to convert that percentage to a decimal. In this problem, we're going backwards. They gave us a decimal, and we have to convert that to a percentage. So how do we go backwards? Well, one way we can do it, just multiply by 100, and it'll move the decimal place over for us. Or just move the decimal place over physically, twice to the right. Before we moved it twice to the left to turn it into a decimal, but to turn it back into a percentage, we move it twice to the right. So that would be 1.43, and that's the two decimal places we want to use. And this is a percent. Before it was not a percent, but now it's a percent. And this would be our final answer, 1.43%, which is a very generous interest rate. You will not see this in the real world. Only 6.99% is a fairly reasonable one, anywhere from that to 14.99% APR if you say use Discover or some other credit card lender. These are more practical interest rates. It's a very generous one though. I mean, it's $20 of a fee. It's a $20 fee to ultimately borrow about $1,000. It's pretty nice. Does anyone have any questions about this before we proceed? Daisy, you have a question?
Yeah, so you said our formula was A equals P plus PRT, right?
The formula was, what, say that again?
A equals P plus PRT?
That's correct, yeah.
Okay, is that the same as A equals P plus, P1 plus RT?
So the one I'm writing on the screen right now?
Yes, that one.
They
Is
are
that the same?
They're the exact same. We only use this form. We use that form when solving for P only. And I mentioned a little footnote for this up ahead. When solving for P, if you're ever looking for just P, that's when we use that form.
Okay.
That's the only time we ever use it. And mention that right here. So in case you need the reference, right there.
Okay, thank you.
Yep. Okay, so anything else? Not, let's scroll ahead to example 9. So if you're still writing those last few steps, I'll leave that part on the top of the screen there. Example 9. So this one, I know previous semesters I've gotten questions about this, so figured I'd add it to my notes. Use the schedule below to find the annual rate of interest. It's a good keyword there. Find the annual rate of interest. Something about the rate. For a RAL, we'll just simplify the acronym just a loan. A loan of $1,411, which is paid back in 22 days. Okay, so if you have taken a college algebra class before, or taken some class where you might have heard the word or the phrase piecewise function, you don't have to know that wording here, but this is an example of a piecewise function. Basically, we use the row that corresponds to the interval of our loan. So we are borrowing $1,411. So we look at all of these intervals and think, which row does that correspond to? Seems like the third one, because that value we borrowed lies in between $1,000 and $1,500. So we're going to utilize this row. So that's how you interpret this problem. So it really breaks down really easily once you understand that this is just, in fact, a piecewise function. So that means all the other information is irrelevant. All we care about is that row, because we borrowed the amount of money that places us in that row. And for that, they instantly tell us the fee. The fee is $49. So now we know the fee is $49. The loan we borrowed was $1,411. The time is 22 days. We'll convert that later. So out of the two formulas we know, I is equal to PRT, or A is equal to P plus P times R times T. Which one are these? Which one of these are we going to use?
Second one. Second one.
So why do you say the second one?
A equals P plus PRT.
Yeah, why that?
They're trying to find the interest and the, trying to find a rate, so you combine the principal and the interest.
So the interesting thing here, it's going to be the first one. And the only reason why, and my last class is the same exact thing as you, so there's one thing that would lean me more towards the first formula as opposed to the second one. That word, fee. That word, F-E-E, fee. Fee is just a fancy way of saying interest. So that means they're telling us the interest. That means we know I. They're telling us I, in other words. So the interest is 49. That's exactly what they're telling us. So this problem's a little tricky, but seeing that keyword of fee tells us, at least, if anything, we're using the first formula, which tells us which values we should be looking for, a P, an R, and a T, in addition to the I that we were given. The P is the principal, which is, well, how much did we borrow? 1,411. The time is 22 days, but we're going to convert that into years by dividing it by, well, I don't have it written down here, so I'm assuming it's going to be 360. As I mentioned in the last class, my math lab sometimes likes to assume that there's only 360 days in a year. It does have a reason for doing this, but just one of those nitpicky my math lab things. So, and we can go ahead and convert that to a decimal quite fast. Okay, so this was 22 divided by 360, and we get some not so nice decimal. 0.061111. I mentioned this in the last class. With these messy decimals, you have to round kind of whatever you feel comfortable with. I use 6 decimal places, which should work the majority of the time. If you want to be completely safe, you can just use every decimal. Or you can use another little trick I'll show you in a second here. All right, keep that off to the side for now. But the R is unknown. And that makes sense because it does say, find the annual rate of interest. The rate of interest is just the rate. Everything else is just excess wording. So these are our given values. And so let's go ahead and put all this together. This is the formula we're using. 49, 1411 times R times T, which is 0.061111, or whatever rounded form you choose to use. It might look a little bit different, but the final answer will be the same after you round. So from here, since R is not by itself, we have to use some algebra. But we can clean this up a little bit. Taking the order of operations, are there parentheses? No. Exponents? No. Multiplication? Yes. 1411, 0.06111. Now here's that little calculator trick if you don't feel like typing in that number. If you type in 1411 times, there's a button up on the top left and it should say second. Click on that. You go all the way to the bottom right, not to the furthest bottom right, but one to the left of that, and you should see the letters A and S. And this will pop up on your screen. A and S is a placeholder that says whatever your last answer was in the calculator, I'll just put that there for you. You don't have to type it. I got you covered. So it'll already apply that for you. ANS is very helpful. It'll keep you from typing a bunch. And now if you type in ANS again, it's going to be that whatever your last input or your last output in the calculator was. It's very helpful. I use it quite a bit, and it will save you quite a lot as well of time. But let's suppose you rounded like I did, and that's what I'm going to go with, just to be consistent. So suppose you rounded. Get an answer that's slightly different. Notice how the two answers are off by, I mean, 100, let's see, 10, 100, thousands, a 10,000th of a decimal place. So whichever one you choose, and whatever answer you go with, you can jot that down. Whichever one you decided to choose. And after we clean it up here, really the algebra comes down to one more step. Division. The 86 point blah, blah, blah is multiplying R, so we can divide by the 86.227621, and that same number goes right here, so I'm not going to rewrite it. In fact, I want another color as well. Let's get blue as well. Okay, cool. So, cancel, cancel. And now R is equal to 49 divided by that 86.227621 value, which we can now plug into the calculator. So instead of typing in the whole number, I'm going to just use second, down here to ANS. So now it's doing 49 divided by that last number that I put in the calculator. Does it for me, types it in for me. Very convenient command, and I'm going to go with that. 0.5682633, that out of the way, 874. That's what the calculator tells us. So then you put this into my math lab, and it tells you you're wrong. And you think, oh, come on, I just did everything. I solved, I did the algebra. Why is it wrong? Because we solved for R, which is a rate, which needs to be expressed in its final answer as a percentage. A percentage, meaning you have to move the decimal place over twice to the right. Or in other words, multiply your number by 100. And notice ANS comes up automatically. It's pretty cool. Or move the decimal place over just manually. So what this comes out to be is 56 point, and I'm going to assume they want two decimal places. Majority of the problems do. 56.83. And now this is a percent after we move the decimal place. And this is what we can go ahead and conclude as well. So it's a very high interest rate. Does anyone have any questions about this before we look at the last problem from this section? Okay, well, let's go ahead and scroll down to this last problem. So if you went to try to complete the homework, say last night or before, you probably came across this problem in the homework, and you probably thought, what the heck is this even going on about? This is easily the toughest problem in the homework set, this example 10 right here. The reason why is because this radio commercial, that statement they make. So sort of think about the situation. The radio commercial for the loan company is making up their own rules for how much they're going to charge you for a fee. They're not following a formula. They're kind of doing their own thing. And it sounds really good on paper. You only pay 26 cents a day for each $500 borrowed. You think that sounds great. 26 cents, that's really cheap for each $500 borrowed. And let's say you want to borrow $2,315 from this place for 242 days. Let's figure out the fee. It does ask, what amount will you repay? So ultimately, we're going to have to figure out the total amount we repay, not the fee, but we need to know the fee in order to know what to add to the original amount. So we're going to figure out, so this is going to be a two-part problem. So part A is what amount will be repaid? Oh, wait. That's not how you spell repaid. I'm drawing a blank. Is that how you spell repaid? College for 8 years. And
R-E-P-A-Y-E.
Now I gotta look it up. College for 8 years.
P-A-Y-E-D.
Paid.
Yeah, P-A-R-D.
Past tense ID. Oh. I was second guessing it, so okay. It is ID. For 8 years. Like, you remember that. Okay, so with that tangent taken care of. So we'll start off with that. So the first thing we're going to do, so it may sound weird, we're going to figure out the interest so we know what to add to the original amount. How much you repay is how much you borrowed, plus how much the fee was. Put those two together and you're good. So let's figure out how much the fee was as an intermediate step. The interest here, I'm not going to follow a formula. I'm not about to write down PRT. The reason why, the radio station or the radio commercial is doing their own thing. They're saying, forget the formula. We're gonna make up our own rules. And just to follow their words, step by step, 26 cents a day, so 0.26. And so how many days is that for? 242 days. So 26 cents for each day, and there's 242 days. So we have this so far. We're going to tack on more to it because it says we do this each time you borrow $500. Now let me ask you an interesting question. If I borrowed $1,000, how many times am I borrowing $500? Twice. About $2,000. Well, I already kind of gave it away. 4 times. What about if it's a number that is not divisible by 500? You can easily just count 500, 1,000, 1,500, 2,000. But what about 23 or 2,315? Is it just a fraction? Do I just put down half a pinky or something, or whatever that value, or half a thumb, I guess? But the so how are you getting that number 2 and 4? Well, it's really a division, what you're doing in your head. It's very interesting, the implicit connection we make there as humans. So what's 1,000 divided by 500? That's 2, because that indicates how many times does 500 go into 1,000? Or how many times does 500 go into 2,000? 4 times. So what we're doing is we're taking the amount in question and dividing that by 500. And that, in essence, tells us how many times does 500 go into 2,315. So if you try to look at help me solve this, it's going to state this with it states this in a much different way. I didn't like their way, and this was the best way I could think about it as. So if you were in that situation, hopefully it didn't freak you out too much. So this is just calculator work. This is the interest. This is not following a formula. This is how the radio station is defining their own interest. They're doing their own thing right now. And so we're going to put all this in the calculator. 2 times 2315 divided by 500. And this is the fee. 291.32, because this is money, so I'll round it at cents. But this is not the final answer. Now that we know the fee and we know the amount we borrowed, we just put those together and we get the final amount. So in other words, the final amount is equal to the original amount plus the fee. So the amount we borrowed was $2,315. The fee for borrowing that was $291.32. So you can do this in the calculator. ANS is helpful. Or you can just use the 291.32 plus 2315. Either way, you'll get the same answer after you round. And I don't know why I wrote it. 2606.32. And that is the amount you would pay back. So if you borrowed $2,315 for 242 days, how much would you pay back? After that allotted time, $2,606.32. But now part B wants to know what annual rate or what annual interest rate is this company actually charging. So we think, wait a minute, that's a lot of money we're paying back. We borrowed $2,300 and we pay back $2,600. What kind of interest rate are you charging here? Is this fair, or can I go somewhere else and get a better deal? So what is the rate, in other words? And remember, we have two formulas at play. We have two formulas. The I is equal to PRT, and the A is equal to P plus P times R times T. I can ask you all, which one would you use? And there's no right answer. We could technically use both. We know what I is and we know what A is. We have a lot of information in this problem. I'm going to use the top formula because it's a little bit simpler. There's just one less variable. There's not as many P variables there. So I is equal to PRT. The interest, we said, was $291.32. So this is for part B, if that helps. What I'm about to write, the I, the P, the R, and the T. The I was $291.32. It was found in that intermediate step. The P value, the amount we started off with or borrowed, that was $2,315. Times the rate, which we don't know, times the time, which is 242 days divided by, so we convert to 360, or divide by 360 days in a year, as the assumption by my math lab. 242 divided by 360. Get this out of the way. Make a little bit more room, so let me put this down here. 0.672222. You can put as many twos as you desire, or use the ANS command, whichever one you feel more comfortable with. And so that tells us exactly what to put right here. 0.672222. And this problem now works out just like the previous problem did, the same exact way. Multiply these two numbers together. 291.32 is equal to that product, which if you want the pure exact answer, 2315 times second ANS. And I'm just going to go off of that one. They're going to be the exact same, or almost the exact same. 56.194444 times R. And then finally, we divide both sides, as we did before. I'll just go ahead and skip. So I'll do two things here. 291.32 divided by that answer, or you can type out the whole number if you want to. And I'm also going to multiply by 100. Why am I doing that? It's kind of weird. It's a percentage. I'm going to move the decimal place over. So I'll just do those steps in tandem. To obtain the percentage of 18.72%. And that is the rate of interest charged. So it sounded really good on paper when they said 26 cents for every $500 borrowed each day. But when you extrapolate the information, then you see that, okay, that's a pretty high interest rate. I'm going to go somewhere else. So clever marketing, very clever.